All right, sorry, Joe, I ran out of time there, so I'll keep going. I'm almost done. Anyways, so we were on step 2, right? So, of course, question 1, age and height, we're going to see a positive correlation to that, right? Right here, this first point would be like when you're first born around 2, 3, you're pretty small, and then as you get older, you're going to see an increase in your height based off how old you get. And then, of course, your final one, age and time needed to run a certain distance. So, as your age increases, time will decrease. So, right when we're old or younger, we can run pretty fast, we can go farther distances, but as we get older and weaker and our bones become, old and weak, we're going to be able to run smaller distances. Okay, so we're going to see a negative correlation to that, right? The longer, farther you can run, the older you get, it's going to decrease. Negative correlation. Hopefully that makes sense for you. So let's keep going. So sometimes points on a scatter plot are represented by a trend line or a line of best fit. So we're going to kind of talk about how we get those and what we can do. So you can study the line to see how the data behaves. You may have a basis predict what the data might be for values not given. So we can always do a little prediction on where our line of best fit is, and that's in reality what a line of best fit is. So example 2, find a line of best fit for the scatter plot you made on the first page. So that very, very first slide where you're trying to look at the trend. So go ahead and pause and try to think about where that line of best fit would go. To fit the line of best fit, or to fit the line to the points, choose your line so that it best matches the overall trend. The line does not have to pass through any of the points, right? It doesn't have to pass through any of the points. We're just trying to see, like, if we were to put a line of best fit to represent the correlation between the two variables, where would it go? So we can say it would, statistically, if we're looking at these two variables, where would I put our points line? Of course, our points might fall outside of that line, but we're trying to get to as close to that line as possible. And so if we're looking at this is where you should have put your line of best fit if you were practicing this. So if we were to look at this, we were thinking, okay, well, our line should go somewhere in the middle of these points, right? We have some outliers here. We have some lower ones. So our line should go somewhere in between. So if you think about in between, we're going to kind of want the same number of points above our line as below our line. So if I was to draw this, I would put it about right there, right? We have 1, 2, 3, 4 points above it, and then we have 1, 2, 3 points below our line. So our line of best fit would kind of go right here. Okay. Now with line of best fit, I'm going to quickly talk about this. We can actually create our equation that's connected to our line of best fit. And how to do this is that you're going to use a slope formula. If you remember our slope formula, you're taking your y1 minus your y2, and you're going to put that over your x1 minus your x2. If you need to write that down, you can. But that's how you do your slope, y1 minus y2 over x2 or x1 minus x2. It doesn't matter which order you do your x1 or y1. You just have to keep it consistent. And then we are going to use, right, our point slope formula that we talked about to find your y-intercept. Okay, your point slope formula, you should have notes on that. So you need to use that formula using our points to find that y-intercept. Now you're probably thinking, where am I going to get my y1 and my x1 and my y2 and my x2? Well, do you see how I hit 2 points with my line of best fit, right? You don't have to hit 2 points when you're drawing your line of best fit, but it's beneficial so you can draw that line or you can create that equation. Let me know if you have any questions on that. So if the trend continues, we predict that prediction, right? Scatter plots are always really predictions. We use it in statistics. But if the trend continues, we predict that there will be 1,200 tornadoes reported in 2015, right? My line should be a little bit to the right, but about 1,200 tornadoes reported in 2015. So you would see that positive correlation. So the data points are close to line of best fit. It is said to have a strong correlation. Do you know how I was kind of saying weak correlation at the beginning? So we can have a strong or weak correlation. So this one right here, I would say have a pretty weak correlation, a weak positive correlation. This has a strong positive correlation. This one has a weak negative correlation, and then this one has a weak or strong negative correlation. Okay, I'm kind of talking fast because most of the time. All right, that is it. All I have for you. You're going to go ahead and practice this now on your activity that I'm going to give you right now. If you have any questions whatsoever, please let me know. But scatter plots, that's really the gist of it. All right, Joel, have a great day. I'll talk to you later.